Ever wondered about the difference between generative and discriminative models? This question often pops up when we first dip our toes into the ocean of artificial intelligence. You see, these are two common types of AI models, each with its own set of rules and unique characteristics. They're like two different languages, each conveying its own version of the truth. Intrigued yet? Stay tuned as we delve into the heart of these models and unravel their mystery. To understand these concepts, we first need to know what an AI model is. In its simplest terms, an AI model is a mathematical construct, or a computational mechanism that's designed to mimic and understand complex patterns or behaviors. Think of it as a virtual brain, capable of learning, understanding, and making predictions based on the data it's fed. AI models are the heart of machine learning. Machine learning is a subset of artificial intelligence that uses statistical techniques to give computers the ability to learn from data. It's like teaching a toddler to recognize shapes. You show them a square, a triangle, and a circle over and over again. Eventually, they start to recognize and differentiate between these shapes. That's essentially what we're doing with AI models, but on a much larger and more complex scale. AI models are trained using data. Data is the fuel that powers AI. The more data we give to a model, the better it gets at understanding patterns and making accurate predictions. This is the essence of machine learning, the ability to learn from data and improve over time. Let's consider an example. Say we have a model designed to predict weather. We feed it historical weather data, including temperature, humidity, wind speed, and so on. The AI model then learns from this data and uses it to predict future weather patterns. There are different types of AI models, each with its unique approach to learning from data. The two types we will focus on today are generative models and discriminative models. Generative models try to mimic or recreate the data they're trained on. They generate new data instances that are similar to the training data. On the other hand, discriminative models focus on distinguishing between different types of data. They classify or differentiate between data instances. In other words, generative models are like artists, creating new works based on their training, while discriminative models are like detectives, distinguishing between different types of data based on their understanding. Now that we have a basic understanding of AI models, let's move on to generative and discriminative models. First off, generative models. They're like the imaginative artists of the AI world. Generative models are a subcategory of machine learning models. Picture them as the creative spirits, the ones that love to create and reproduce. Instead of just classifying or predicting things, they take it a step further. They're all about understanding the underlying structure of the data and then using that knowledge to generate or recreate data. So, how do they work? Well, imagine you're an artist trying to paint a sunset. You would first study several sunsets, understand their colors, the way the light interacts with the sky, and how the clouds form. Once you've learned all of that, you can create your own sunset painting, even if you've never seen that particular sunset before. That's what generative models do. They learn the patterns and the structures in the data, and then they use that knowledge to generate new, unseen data. Let's simplify this with a basic example. Think of a generative model trying to learn how to write like Shakespeare. It would first study all of Shakespeare's works, learn his style, vocabulary, and sentence structures. It would then use this knowledge to write a new Shakespearean sonnet, one that isn't in any of the existing works, but still sounds like it could have been written by the bard himself. Generative models are used in a variety of applications, from generating realistic human faces, to creating music, to even designing drugs for new diseases. They truly are the imaginative artists of the AI world, constantly creating and innovating. But it's important to note that these models are not perfect. They're only as good as the data they're trained on. If the data is biased or incomplete, the generated output will reflect that. So, generative models capture the data's distribution to generate new data. Now, let's contrast this with discriminative models. Now, onto discriminative models. They're like the detectives of the AI world. Discriminative models, in the simplest terms, are all about differentiation. They don't bother too much with understanding the intricate details of each class or category like generative models do. Instead, they focus their energy on finding out what sets one class apart from another. Think of it as a detective, who is less interested in the backstory of each suspect, but more on finding the key differences that would allow them to identify the culprit. These models work by learning the decision boundary between different classes. To put it in simpler terms, imagine we have two piles of fruits, one of apples and one of oranges. A discriminative model doesn't care about how the apples and oranges grow, it cares about how to differentiate an apple from an orange. It might look at color, size, or texture to make this distinction. Now, let's dive into a simple example. Suppose we have an email filtering system that needs to differentiate between spam and non-spam emails. A discriminative model would look at aspects like the frequency of certain words, the sender's email address, or the time of sending to discern patterns that separate spam from non-spam. It might realize, for instance, that emails containing the word prize sent from unknown addresses at midnight are often spam. It's important to note that discriminative models are generally more accurate in their predictions than generative models. This is because they directly focus on the task at hand, which is differentiating between the classes, rather than trying to understand the distribution of each class. However, this strength can also be a weakness. Since discriminative models don't try to understand the distribution of each class, they might struggle when faced with new, unseen data that doesn't fit the patterns they've learned. So, discriminative models focus on the decision boundary between classes. Quite different from generative models, right? Alright, it's time to pinpoint the key differences between these two types of models. Generative and discriminative models, while both integral to the world of artificial intelligence, have contrasting characteristics and uses. Let's start with how they approach learning. Generative models, as the name suggests, are all about creation. They learn the joint probability distribution of input and output data. This means they're trying to understand how the data was generated, to then be able to generate new data points. On the other hand, discriminative models are more focused on the divide. They learn the conditional probability of the output given the input, essentially discriminating between different outcomes based on the provided input. Now, onto their uses. Generative models are your go-to when you need to generate new data. They're great for tasks like creating realistic images, synthesizing speech, or even composing music. Discriminative models, however, excel in classifying or predicting outcomes. They're commonly used in applications like email filtering, image recognition, or speech recognition. In terms of advantages, generative models are known for their flexibility. They can manage missing data and are able to handle unsupervised learning tasks. Discriminative models, on the flip side, often outperform generative ones when it comes to supervised learning tasks. They can provide more accurate results given enough data. However, both models come with their limitations. Generative models can be computationally expensive and often require a lot of data to train effectively. Discriminative models, while generally more efficient, may struggle with tasks that involve generating new data. So to sum it up, generative models are about understanding and recreating the process that generates the data, while discriminative models are about distinguishing between different data outcomes. One is not inherently better than the other, rather, they each shine in their respective areas. As you can see, generative and discriminative models have their unique strengths and applications. So why does this all matter, you might ask? Well, the answer lies in the heart of artificial intelligence itself. Understanding the differences between generative and discriminative models is not just about knowing how AI works. It's about recognizing the potential of these models in real-world applications. Let's think about it. Imagine a world where artificial intelligence can create highly realistic images or sounds, or even predict what's going to happen next based on patterns. These are not mere flights of fancy. They are real possibilities with generative models. On the other hand, think of an AI that can accurately classify, say, whether an email is spam or not, or identify diseases from medical images with precision. This too is within reach thanks to discriminative models. But the real magic happens when these models work together. Picture a self-driving car. It needs to generate possible scenarios, generative models, and then discriminate which one is most likely to happen, discriminative models. The collaboration between these two kinds of models is what makes such advanced technology possible. Moreover, these models are not static, they are continuously evolving. As we speak, cutting-edge research is being conducted to refine and enhance these models, shaping the future of AI. This is why understanding them is so crucial. It gives us insights into where we are headed and what we can achieve. The world of AI is vast and complex, but understanding these models brings us one step closer to mastering it. So keep learning and stay curious.